Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. What is a neutron star? Scientists tell us that the material left over from a supernova explosion of a massive star collapses gravitationally, forming a very small and incredibly dense star mostly composed of tightly packed neutrons. A rotating neutron star will emit regular pulses of radio waves, called pulsars. It was the completely unexpected observation of these radio pulses in the 1960s that led to the invention of the neutron star hypothesis. However, in several previous Space News episodes, we have discussed recent discoveries that in effect falsify the foundations of this theory. Today, Professor Donald Scott discusses yet another fatal discovery for the theory of neutron stars, and he lays the foundations for an alternative explanation in the disciplines of plasma physics and electrical engineering.
One of the interesting things about this latest Vela pulsar press release was, in my opinion, the release actually says something quite different from what the astronomers intended to say. And I'll try to explain what I mean by that in just a couple of minutes. Clearly, the mainstream view that they, of course, support is that pulsars are stars that periodically put out flashes of light and other electromagnetic radiation. And the obvious analogy to this is a lighthouse. Of course, a constant beam of light that rotates around so that the observer only sees a flash during the instant that the beam is pointed directly at him or her. So the star is thought to be emitting a narrow beam of light and rapidly rotating. Well, that's fine. This explanation works for a while until one realizes a couple of things. Number one, how rapidly the star has to be rotating to produce these flashes in millisecond time. And two, that the Earth, where we all do our observing from, must be exactly in the beam's plane of rotation. Whereas the beam can't be looking off somewhere else and we wouldn't see it at all. So it's got to be very precisely in alignment. And is that logical or is that probable? Well, you have to think about that. Anyway, the astronomy picture of the day, the APOD, the famous APOD, way back on June 9th, 2002, contained an image of the Vela pulsars, just the same image, I think, as the one they put out the other day. That APOD called this pulsar a neutron star ring jet. And the picture of the jet is there. This latest release talks about something about a counter jet and it's new. And so it's not new at all. It's back there in the same picture back in 2002. So I don't know really what they're talking about as far as the counter jet is concerned. It's clearly not an aligned jet that would be the one that's doing the rotating and flashing at us, because that's fixed in space, that jet that we see that picture of. Anyway, the official explanation back there in 2002 said that the Vela pulsar is a neutron star, more massive than the sun. It has the density of an atomic nucleus, and it's about 12 miles in diameter. Now, this latest one, I think they said it was 18 miles in diameter. So whether they think it's grown or whether they have a different idea, I don't know. But the point is, it spins 10 times a second. Now, 10 times a second is 600 RPM. So, okay, envision this. It's a star. It's more massive than the sun. It's somewhere between 10 and 20 miles in diameter, and it's rotating at 600 RPM. But obviously, a star that rotates completely on its axis 10 times a second would fly apart. It's obvious. And so knowing this to be the case, astronomers came up with the ad hoc invention, the neutron star, a star made up of only neutrons, densely packed like the center of an atom. Unfortunately, the problem with that one is that neutrons don't remain in compact bunches. There's no such thing as a neutron-neutron pair. And we know from lab experiments that any lone neutron decays into a proton, an electron, and a neutrino in about 14 minutes. So atom-like collections of two or more neutrons will fly apart almost instantaneously. There cannot be any such thing as a neutron star. So some astronomers have begun to realize that neutronium is sort of absurd. And what put the finishing touches on that, I think, at least for some of them, was the discovery of an X-ray pulsar located in the constellation of Sagittarius that flashes every 2.5 thousandths of a second. a flash every 2.5 thousandths of a second. That means that if this thing is a rotating lighthouse beacon, it's rotating at 24,000 RPM. So here you got something, it's a star, miles in diameter, and it's rotating at 24,000 RPM. That's the speed of a dentist drill, just about. And it goes way beyond the red line for even a neutron star. So another explanation was invented very quickly, pulled out of the back pocket, already added to a long list of inventions that astronomers have made. And this one is that pulsars must be composed of something even denser than packed neutrons, even denser than neutronium. They call it strange matter. Remember that we have missing matter and we have dark matter. So here's another one for the list. This is strange matter. Anyway, this latest announcement does not express any doubts at all about the lighthouse model, but it was concerned that the periodicity was varying. And I can quote from the release, it is known from previous studies that Vela regularly speeds up in rotation frequency, approximately every 3 years, and also experiences microglitches. A glitch is a change in the rotation speed, a change in the period of the pulses, the pulse train. And the new research showed that Vela's pulse width changes over time, and it changes sharply at certain periods of time. Okay, that's fine. Well, but if you look then at the abstract of the release, it says, and I'm quoting now, the mechanisms of emission and changes in rotation frequency, that is the glitching of the Vela pulsar, are not well understood. Can I repeat those 3 words? They're not well understood. Well, the very next sentence says, further insight into these mechanisms can be achieved by long-term studies of integrated pulse width, timing residuals, and bright pulse rates. Translate that into English, that says, we don't have any idea what's going on now, but if you give us more time and more money, we'll invent some other good explanations down the line somewhere. At least that's my suggestion. Anyway, astronomers are worried because the new data about glitches means that their massive star must instantaneously vary its rotational speed by thousands of RPM. So if you think about it, you've got this horrifically massive monster out there going at 24,000 RPM, or at least several hundred, if not thousands RPM. And all of a sudden, boop, you put the brakes on it, and it has to stop or slow down and then speed back up again. And how this happens is it's just mind-boggling. In my estimation, what it does is it defeats the model. It clearly falsifies the lighthouse model. But there's a more realistic explanation, and that more realistic explanation is, in my estimation, electrical. What we're looking at in pulsars are strobe lights, and strobe lights have been around since the 1930s. There's a company, EG&G. It was founded by Harold Edgerton, a fellow by the name of Germishausen, and another guy by the name of Greer. So Edgerton, Germishausen, and Greer came into business in 1947 as EGG. And what do? They manufactured strobe lights. And the heart of a strobe light is just a small bulb containing a plasma driven by a very simple electrical circuit. And one such electrical circuit is called a relaxation oscillator. And you can see in the picture that it can consist of nothing more than a resistor, a capacitor, a voltage source, and a gas tube, a little glass, or even in the case of here on Earth, a glass tube, or out in space, it doesn't need a glass tube. It could just be a cloud of plasma. And it can put out pulses of light at various periodicities and pulse widths. So you can see from the diagram there that what happens when you first connect the 6-volt battery, and everything, let's say, is dead, the capacitor is uncharged, the light bulb is turned off. When you connect the 6-volt battery to the resistor, it begins to pump current through the resistor into the capacitor and charge up the capacitor. Now, no current goes into the light bulb because the light bulb, the plasma, is turned off. It hasn't reached its firing voltage yet. Its firing voltage is way up there at 5 volts. So what happens is the current goes through the resistor down into the capacitor. You can think of a capacitor as sort of like a bucket that holds charge, just like you'd fill a bucket of water up with water. And as you fill it, the height of the water in the bucket gets higher. Well, as you pour more and more charge into a capacitor, the voltage across the capacitor is just like the water level in the bucket. It gets higher. And so you can see how that voltage builds up in that exponential rise that is heading up towards 6 volts. If nothing happened to deter it, it would approach 6 volts in an infinite length of time exponentially. But it's interrupted by when it gets to 5 volts, the bulb says, ho ho, that's my firing voltage. Bingo! It emits a flash of light. It becomes a short circuit and discharges the capacitor. All the charge that has been in that bucket of that capacitor is dumped into the light bulb in an instant, a flash. And that's what gives the familiar strobe light, that brilliant instantaneous flash. The length of time that it takes to charge up is a product of the resistance times the capacitance. You take the resistor value in ohms and the capacitor value in farads, and you multiply the two of them together, and that gives you the time constant, the so-called RC time constant of that exponential voltage rise, and that will give you an indication of how long it's going to be between flashes. So you want to make it more rapid? Well, reduce the R or reduce the C, or possibly both of them. And so you can play games with the values and do all sorts of things with the periodicity, and you can certainly vary it. So if we have a pair of stars, a binary pair of stars out in space, and if they're closely spaced, there may very well be a plasma bridge between them. And the resistance in the relaxation oscillator is the resistance of that plasma bridge. And so the capacitance value depends on the surface areas of the two stars. And if one of the stars is being driven by an external current to a higher and higher voltage, clearly this kind of oscillation is possible. Also, voltage pulses can bounce back and forth along a plasma bridge. If we have a plasma bridge that connects the two stars and we get a voltage pulse that goes from one to the other, it can bounce back again. And there's all sorts of possibilities for reflections of pulses on high voltage power transmission lines. And in 1995, an analysis was performed by Peratt and Healy on a transmission line system having the properties that they believed to be those of a pulsar atmosphere. Well, they could explain in those experiments 17 different observed properties of pulsar emissions in those experiments. They could imitate glitches, they could imitate varying pulses, they could change the width of the pulse itself. All sorts of things are possible, and it can happen very, very quickly because all you have to do is change the resistance value of a plasma, and that's very, very simple and probably does indeed happen in space. So we know that neutron stars made up of neutronium are impossible. Strange matter is impossible. And if we're not willing to discard everything we know about the physics of materials, we know that new science of things like strange matter is not really acceptable science. The real explanation is an electrical one, and it's been around since the 1930s, and it's really quite simple. Just as a sort of an addendum, people might notice the similarity in the shapes of the exploding plasma shape obtained from a plasma focus device, which is another device which has been around in plasma laboratories for decades. Umbrella shaped, a sort of a double umbrella that's coming out the right side of that plasma focus. And if you compare that with the Vela pulsar picture, they're almost identical. Let me just finish by saying a sort of a personal note. A couple of years ago, a defender of the lighthouse model told me that the extreme regularity of a pulsar was proof that they could not be electrical. Electrical circuits would be too unstable to produce those absolutely regularly periodic pulse trains. So now with this announcement, it seems to me, at least, that astronomers are perplexed about the irregularity of these pulse trains. And so the worm has turned a bit, I think, and what they thought was a defense of their model now is another thing added to the list of probable falsifications of their lighthouse model. And all I can say is imagine the torques that would be necessary to slow the rotation of a star and then speed it back up again. Now, the lighthouse model is falsified, and I'm just wondering how long it's going to take them to admit it.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.